Welcome to our Feature Flag series, part 2. I hope you enjoy. To implement our feature flags solution, we need a way to save and retrieve data about the flags. And here we have two different structures for that. The first is the one we are going to use in our database. And the second is going to be cached in memory by the application for performance reasons. Note that our database structure has additional information about the flags. Here, description allows us to know for what purpose the flags being used. It's important to have some level of documentation about the flags to improve maintainability. We have information about each environment as well. The application can be running on staging or on production, for instance. The inner part are the user groups. The whole idea about feature flags is to control which users will have access to those new features. In this example, the users are distributed in two groups, those with access to the new feature and those that don't. The idea here is to be flexible, allowing to create more than two groups. On the other hand, in memory, we don't need to know about the environment. The environment is already set when the application is deployed. So the application should know in which environment it is running. And then it can use to load the flags data and cache it in memory from time to time. But we still need to keep the information about the groups because we don't know which user is accessing the application. This is good because we have less data in memory and a faster data retrieval. Now that we have the structures we are going to use, we can decide how to implement them in TypeScript. For the groups, we are going to use the utility type record, which represents an object with its properties and values. And we are doing that because we should have a small number of objects here, usually two. One to represent the group that have access to the new feature, and another for those that don't. So we don't need to be much concerned about performance. The user group name is the key and the flag's content the value. But for the flags, we should have a larger number of items. So we are going to use the type map, which is a hashed data structure. Map, it's an interesting choice here because it has a big O of 1 in terms of time access, and it is usually faster than using the object key as an index. The flag name is the key, and the groups the value. So to find a flag, we are going to need two arguments. The flag's name to find the groups, and then the user group name to finally get the flag's content. And here it's our code. It's basically the types we have defined, but note that I'm using the types flag name and the user group name as aliases for a string. In my opinion, this helps the code to be more readable. As a developer, it's always a good practice to explicit our intentions in our code. This way, if a fellow developer is reading the code, they don't need to infer about what we are using as keys. Another thing I did was to delete the Lerna demo function because it's no longer necessary. And now we are good to write our tests. Let's start with a variable that represents the flags cached in memory. The idea is to load the flags before all test cases. Then, let's create a function to mock the user groups using the same naming we have used in our initial presentation. Note that using parameters, we can mock different data combinations.
we also need a function to mock the feature flags structures we are using to cache data in memory. And now we can create the function to get a flag from the mocked data, giving the flag name and the user group name. Keep in mind that if the flag does not exist, the groups will return undefined. When testing, it's pretty common to need to run something before or after a test case. Vitest offers some hooks for that. Before all test cases, before each test case, after each, and after all. But keep in mind, they only work in the current context, inside the current described block. Here we are adding a before all hook to mock our feature flags cached in memory. As we are not changing its content, we don't need to do this before each test case. If you are enjoying so far, please let me know if you want more content about testing with Vitest, leaving your comments below. And don't forget to subscribe. Finally, we can write the test cases. We are going to add 3 tests. One to retrieve an existing flag, another to fail because the flag does not exist, and the last one to fail because the group does not exist. Note that we are using equal with an L at the end because as we are comparing objects, we want to do a deep comparing. And here, we are just confirming if it's returning undefined. Let's use Lerna now to run our new tests. It seems we are good here, so we can work on our flag client class. Our flag client class is going to be responsible for loading the feature flags from a data source, refresh them from time to time, and retrieving a flag using its name and user group name. But if we implement the function that loads the flags inside our class, we need to decide which data source we want to use and be committed with that. Or we need to implement different loaders for different data sources. Considering the open-closed principle, we want to avoid to modify our class each time we want to read from a different data source. So, our solution is going to implement the loader outside our class and then injecting it in the constructor using dependency injection. This solution allows us to have different loaders for different data sources, and they are going to be totally independent of the class. Besides that, this is also good for testing. We can test our loader totally isolated from the class. And the class can simply mock a loader. But enough of that, let's coding.
we are going to use a static factory method instead of directly calling the constructor. This approach is interesting because we can have a more meaningful name when creating the object. Our static method can be an async function, what is not allowed for a regular constructor. And we need a sync function here because our loader could be reading from a database or from a request, for instance. Here, we are caching our flags for the first time. We need to be sure that after creating a flag client object, we have our flags already cached. As we are using the static method to create our object, we can set the visibility of the constructor as private. And now, we need to decide which arguments we are going to pass to the start method so we can create the object. And for that, we need to add some new types. We are going to declare a starting options type for our static method. We need first to inform from which environment the flags should be loaded. In our solution, the application must know in which environment it has been deployed. Usually, the applications have this information stored in an environment variable, as node env. Although we want to refresh our cached flags from time to time, it's possible to have a use case where the developer wants to control the refreshing manually. For that be possible, we are going to use a Boolean property to indicate if you want or not an automatic refresh. If the auto refresh is set to true, it is also interesting to have a property to indicate the refresh interval. Here, we are considering the time in seconds. At last, we need to pass the loader function to be used. Note that the class do not need to know from which data source the flags are being read. The loader function expects a single argument that is the environment to be considered. With the types defined, let's use Lerna to build the package and update the node modules. Our types should be available now, so we can go back to our class and finish its implementation. You should have already noticed that we are using the types we have just declared. We need to store the loader function because we need to call it inside our refresh method. Flags represents our cache data memory. We need an interval ID because we are going to use set and clear interval. In mind that if auto refresh is off, the developer is going to need to call refresh directly. Otherwise, it is going to be called in our set interval. We are passing the interval ID to clear interval so we can stop refreshing.
As refresh interval is optional, we are using a default duration in case the interval is not provided. Keep in mind that set interval expects time in milliseconds, so we need to convert here. And we can't forget to add a method to get the flag. The logic is very similar to that one we did when testing types. We are cloning the flag here because we don't want to return the reference, only the value. Okay, let's now build our client package to check if everything is okay so far. So we are good for today. And in our next video, we are going to write the tests for our class and explore more about feature flags.
If you enjoyed the video, please don't forget to smash the like button and subscribe. Thanks for watching, and I see you in the next video.